Today's lecture is on our general linear model 2, and this is going to be comparing means adjusted for other predictors, or also known as analysis of covariance. And so this is a Ancova rather than an Anova. It's an Ancova for analysis of covariance. And so what the Ancova is basically is it's adjusting the relationship between the independent and dependent variable based on a secondary variable that believes is having an effect on the outcome variable. So it's kind of taking account for one variable to understand the relationship between an independent variable and a dependent variable um, better or more accurately. So to test for differences between group means, when we know that an extraneous variable affects the outcome variable, we can use what's called an Ancova, or analysis of covariance. So what we do is we adjust for the known extraneous variable to help us understand better the relationship between the independent variable and the dependent variable. The extraneous variable is often referred to as the covariate. So that the way that the Ancova works, or the advantage that the Ancova provides, is it helps to explain some of the unexplained variance. The way that the ANOVA, or the basic ANOVA, works is you compare the sum of squares model and divide it by the sum of squares and a residual. Of course, you have to divide both by the degrees of freedom and then get to your mean squared for both. But the basic comparison is between the amount of variance that's explained by the model and the amount of error that's in the model. And the error in the model is given to us by sum of the squares residual. So what the Ancova does is it helps to reduce the error variance. It tries to account for individual differences in some extraneous variable to help produce a more realistic or more accurate result. So by explaining some of the unexplained variance, the error variance in the model can be reduced. And then by controlling for known extraneous variables, we can gain greater insight into the effect of the predictor variables. We know that for the most part, most things in life have multiple, especially in psychology, have multiple causal variables at play. There usually isn't simply one thing that causes another thing. There's going to be several different things. So what this allows us to do is to account for other kinds of variables that may be affecting the type of relationship we're looking at between the independent variable and the dependent variable by looking at the extraneous variable, or the covariate. Now, the example we're going to look at today is we're going to go back to the puppy therapy example that we looked at before. And so one of the possible confounding or extraneous variables was how much people love puppies, or how much people love dogs. So for example, for me, as you probably remember, I hate dogs. I don't like dogs. I wish they'd go away. And so it's probably the case that to account for my non-love for puppies, that might have an effect on the ability for puppy therapy to actually work on me. It might play some role in that. And so what this example is going to do is going to take account for each individual's love of puppies, or how much they like dogs. And then we can replicate the earlier study to see, which has the same predictor variable, or independent variable, how much puppy therapy someone received, and then how much it affects their particular happiness, while accounting for each individual's love of puppies, or how much they like dogs. So if we go to JASP, so here's the file. It's if you want to work with it, it's the one entitled "I'm a Puppy Love." And so you'll notice that we have a few different variables. You don't have to worry about the person, that's just each number. The dose and the happiness are the same. Okay, so that's what we were looking at before. The groups are a little bit bigger this time. And notice that we now have a third variable. This is our covariate, and that is puppy love, or how much people love puppies or dogs. The covariate, if you'll notice, will always be a scale variable. The covariate will always be a scale variable. And it's that scale variable that we're going to take into account when looking at the relationship between these two variables. So to begin with, let's just do a normal ANOVA to see what kind of results we get when we don't take an account for puppy love. So we'll take dose. That's going to be our fixed factors, meaning how much puppy therapy each person received. And then we'll take note of happiness. And notice how when we just do that simple test, notice that it's not significant. So our F value is 2.416, and then our P value is 1.08. So on this first analysis of this data, it would seem to be the case that puppy therapy does not have an effect on happiness. But with Ancova, it allows us to take account for or reduce that error variance by looking at this covariate or this extraneous variable that may be having some type of an effect. So to do the full Ancova, we simply take puppy love. We'll bring it in here as a covariate and notice how our values change. Notice our F value has increased, and now it is actually significant. Now there's two things to consider here. One is we're looking at did the covariate have an effect, and it actually did. So there, it does seem to be the case that the puppy love has an effect on the overall happiness. And when we take account for that, it also makes it the case that we can also say that the dosing does have an effect, because notice it's changed our F value and our P value. So that allows us to see that this covariate does have an effect on this particular model. Now, the other way we can do that is to actually represent that graphically. So let's go to descriptives. And let's take these two, let's take the dependent variable and the covariate. And because they're both scale, let's just do a correlation plot. So take the correlation plot and notice here, notice how we do have a relationship between these two, that as one increases, so does the other. As puppy love increases, so does the amount of happiness that someone received from engaging in those particular therapies. So we can see that there's a relationship here, and that this covariate is obviously doing something or having some type of a effect. Okay, so let's go back to our Ancova. Now, so what the covariate does is it's just adding a little bit more to our model of the relationship between the independent variable and the dependent variable. So the same sorts of things can still apply. So let's go back and let's go ahead and do the contrasts. We'll do a contrast just like we did before, except this time we'll just do a simple contrast. Okay? And what the simple contrast does is it essentially just compares the control group, or the first group, to the other two. So when we do that, we find that both were significant. Control compared to 30 minutes was 2.77. Our p-value is below 0.05, and the same thing was true as well between control and the 15 minutes. So finally, the other thing we'll want to have, of course, just like we had before, is we'll want to have our plots as well. So take the dosage, display error bars, and then that'll allow us to have our same descriptive plots as we had previously. Okay, so with the Ancova, it's fairly straightforward. There's not a whole lot more to do than that. It's simply adding something more to our Ancova model. It's just giving us a little bit more kind of information, helping us to account for the independent variable and dependent variable relationship. So when we write these up, come down here, the way that we write these up is first off, we will list the covariate. So the covariate love of puppies was significantly related to the participant's happiness, and we'll list the F value, P value, and then the eta squared as our effect size. So that's the first sentence. And then the second sentence, there was also a significant effect of puppy therapy on levels of happiness after controlling for, this is kind of the important part, or the part that changes in reporting these results is you say there was a significant effect after controlling for the covariate. So after controlling for the effect of the love of puppies, then we list our F values, P value, and our eta squared, or our effect size. And then part 2 is simply going to be reporting the contrasts. So we'll just want to report what kind of contrast this was. So this is a simple contrasts. So simple contrast revealed that having 30 minutes of puppy therapy significantly increased happiness compared to controls. You can write down the T, P values, and then finally, and when compared to having 15 minutes as well. And so we'll list T values and our P value there as well. Okay, so fairly straightforward, not much more than that. I'll give you some homework so you can practice these as well. And as always, feel free to let me know if you have any questions. Talk to you later.